Hi, chemistry students. So we've looked at an introduction to heat, and we have seen the equation Q equals mc delta T, and we've seen one practice problem. So now we're just going to look at a few more practice problems, all right, to try to get us feeling really comfortable with this formula. So I don't want you to be this scared like Andy over here, all right? So we're going to be just fine. All right, so we have a new question. What mass of copper, specific heat of copper is 0.38 joules per grams degrees Celsius, is heated if the copper metal increases 90 degrees C when 15,000 joules of heat is added? All right, so something that I want you to keep in mind, Q equaling mc delta T, I would always list those, all right? You will always be given 3 of the 4 of them in the question, and then you're just algebraically solving for that 4th one. So Q equals 15,000 joules, all right? M, what mass of copper? We don't know, that's our unknown. All right, C, it's given in the question, 0.38 joules per grams degrees Celsius. And the delta T, it doesn't tell us the initial or the final temperature, which is fine. It does tell us the change, though. It increases 90 degrees. So delta T equals 90. Q equals mc delta T. We're going to solve for M. So that means we're going to divide both sides of the equation by C and by delta T. So we're going to get M equals Q divided by C times delta T. All right, so that's 15,000 joules divided by the sum of 0.38 times 90. All right, so that number, when you do 0.38 times 90, you should be getting 34.2. So 15,000 divided by 34.2, we're getting 438.6 grams of copper. All right, so here we were solving for the mass, still using Q equals mc delta T. We did have to manipulate it a little bit. All right, but the same formula, so list those pieces. All right, so now we're going to look at a question where we're going to solve for the specific heat. All right, if you have a high specific heat, he's right, you know. All right, so what is the specific heat of a 150-gram metal that increased its temperature by 95 degrees when it gained 12,800 joules of energy? So again, my advice, list out Q, M, C, and delta T. All right, I would be doing that alongside me with this question. Q, from the question, it gained 12,800 joules of energy. Q equals 12,800. M is 150 grams. All right, so that's the mass of the metal. C, we don't know, right? What is the specific heat? And the change in temperature, it increased by 95 degrees, right? So we don't have the final and the initial, totally fine. All right, so Q equals mc delta T. We want C by itself. So now we're gonna divide both sides of the equation by M and by delta T. So we'll have Q over M times delta T to equal C. All right, so again, there's C, Q over M times delta T. Q is 12,800 divided by 150 divided by 95. 150 times 95 is 14,250. So we're doing 12,800 joules divided by 14,250 grams times degrees Celsius. What's interesting in this question is none of our units cancel, because when we solve for specific heat, it should be in joules per gram degrees Celsius. We should have all 3 of those units stick around. And when we divide, we get 0.90. All right, 0.90 joules per grams degrees Celsius. All right, this is solving for the specific heat. And something that's interesting, sometimes we get these questions and then we look at a chart as reference, kind of like we did with density. We're asked, well, which metal is it? Well, which metal has that specific heat? It would be aluminum. So in this question, the metal must have been aluminum, right? Because it 150 grams of it gained 95 degrees of Celsius temperature when 12,800 joules of energy was added. All right, so if I were a rapper, I'd be MC delta T. A lot of kids like that joke. So how much energy does 45 grams of water, specific heat 4.18, lose when it cools from 70 degrees Celsius to 12 degrees Celsius? So think about what this question's asking. It says how much heat will it lose when everything else has been gained? And it's going from 70 degrees Celsius to 12 degrees Celsius. All right, Q, we don't know. M, 45 grams. It's 45 grams of water. C, 4.18 joules per gram degree Celsius. This was given to us in the question. All right, delta T, T final minus T initial. What's the final temperature? 12 degrees Celsius, right? When it cools from 70 degrees to 12. All right, what's the initial temperature? 70. All right, so when we do delta T, it's final minus initial. 12 minus 70, we get negative 58 degrees Celsius. Q equals mc delta T. M is the mass, 45 grams. C is the specific heat, 4.18. And delta T is negative 58. So we're going to multiply 45 times 4.18 times negative 58. We get negative 10,900 joules. All right. And you will get a negative answer anytime heat is lost. All right. And that means that your final temperature is lower than your initial temperature. This is totally fine. Do not freak out about seeing a negative in these questions. All right. It will happen from time to time. All right. So those are just a few more practice questions. So hopefully you feel ready and prepared to do a little bit of practice on your own. All right. Good luck, guys.